Welcome to This Explainer. Today, we're taking a really fun deep dive into the microscopic world to unpack something called the kinetic molecular model. And trust me, by the end of our time together, the ordinary, everyday objects around you, they're going to look fundamentally different.
So what is everything around you actually made of? I mean, really think about it. Think about the device you're using right now. Or, just a simple wooden pencil. If you could zoom way in, past the graphite and the wood, you wouldn't find a solid, static block. No way. You'd reveal this chaotic, totally invisible reality of constantly moving particles.
Okay, let's dive right into this. Section 1. The invisible moving world.
The absolute foundational concept of the kinetic molecular model is that literally everything around us is made of incredibly tiny particles. And here's the kicker, they are never completely still. Let's look at how this builds. Step 1. We start with the atom, right? The fundamental unit. But atoms rarely travel alone, so step 2, they bond together to form molecules. And finally, step 3, when these molecules group together in just massive quantities, they create matter, the foundational stuff of our universe that actually takes up space and holds mass.
Moving right along. Section 2. Solids. Tightly packed particles.
Think of a block of freezing cold ice. It feels completely rigid, doesn't it? But here's the thing, a solid isn't actually frozen still. Its particles are just packed together so tightly that they simply lack the room to move around freely. So, trapped in these fixed positions, they just rapidly vibrate in place, buzzing with all this locked-up potential.
All right, Section 3. Liquids.
Sliding and flowing.
Now, as that ice begins to melt, the whole structure loosens up. In a liquid state, those vibrating particles finally get a little bit of breathing room. They're still close together for sure, but they break free of that rigid grid, sort of slipping and sliding past one another. And this tumbling action, that is exactly why liquids flow and instantly adapt to the shape of whatever container you pour them into.
Next up, Section 4. Gases. Fast and free.
Now turn up the heat until that water boils and chaos truly takes over. In a gas, particles are moving at absolutely incredible speeds in completely random directions. Because there's so much vast empty space between them, they just bounce around relentlessly. They rapidly expand to fill up any available volume, whether that's a small balloon or literally an entire room.
Which brings us to Section 5. Temperature. The energy engine.
So you might be wondering, what actually acts as the master switch between all these states? Well, it's temperature. And this brilliantly illustrates exactly how it works. On the left side, we see that heating matter basically injects it with kinetic energy. The particles absorb it, they accelerate, and they violently push apart. Conversely, on the right side, cooling drains that kinetic energy away. The particles get sluggish and huddle close together. So ultimately, temperature is really just a measurement of this particle speed.
Finally, Section 6. The big takeaway.
All right, let's synthesize all of this into one clear picture. The state of any matter is entirely governed by two things: spacing and movement. As you can see, solids are packed tightly and just vibrate. Liquids sit close but slide around freely. And gases remain far apart, darting around rapidly. The ultimate rule here is super simple. Adding or removing heat dictates all this hidden behavior.
And remember, this isn't just some abstract theory confined to a laboratory. Science is everywhere. This incredible invisible dance of atoms is happening right now inside the device you're holding, the chair beneath you, and even the blood flowing through your veins. You are literally a walking manifestation of the kinetic molecular model. The closer we look at the ordinary world, the more extraordinary it actually becomes.
So, I'm going to leave you with this one final thought. The next time you're waiting for a pot of water to boil, don't just see bubbles. Ask yourself, just how much invisible kinetic energy are you really watching? Think about how many trillions of molecules are desperately gaining speed, breaking their bonds, and racing upward to fly free. It's a spectacular microscopic event happening right there on your stove. Thanks for joining me on This Explainer. Keep learning, and I'll catch you next time.